single linked list last time. So let's see some more applications of single linked list, and this will be very useful for you to do the questions in your exam, the upcoming exam. Okay. All right. So consider the problem. So what we want to do here is to see how to be able to insert at an appropriate location in the linked list at runtime. So you don't know beforehand the index where you want to insert the element. So you want to be you will get to know where you want to insert only at runtime, and still you should be able to insert at the appropriate location. Okay, so that's what we are going to see. So let us look at this as as an example, the problem of maintaining a list of integers such that it always has the negative integers followed by the positive integers. Okay, so you're going to insert one integer at a time to the list. So only after the user inputs the integer, you know whether it's negative or positive, and then you have to be able to decide where that integer has to be inserted. Okay, and so you want to insert the new integers on a last input last insert basis. That means if a user enters a positive integer, it should be inserted all the way at the end, because you want to maintain a list of negative followed by positive. On the other hand, if the user inputs a negative integer, right, so you want to be able to insert as the last negative integer in the list. So for example, if the number of elements you want to store is 10, you get that as input from the user and ask the user to enter each element. So if the user inputs 23, 23 gets inserted right away because it's the first element, there's no element out there. Then if the user inputs 10, it should be the last element because there's no negative, so after all the positive integers, that's the last element. Whereas negative 45, there's no negative integer so far, so that should be inserted as the first element. Whereas negative 78, you should traverse from the beginning and see that after the negative 45, the next integer is 23, that's positive. So negative 78 should be inserted in between. Then 56, since it's positive, it should be inserted all the way at the end. Then negative 11, then you traverse from the beginning, negative 48, negative 78, and then you see a 23. So at that point, you should insert negative 11 as the last negative integer. The negative 12, again traverse from the beginning, negative 45, negative 78, negative 11, then you have 23. So negative 12 should be inserted right in between. Okay, so that's the logic. And 0 is considered as positive. So if the user inputs 0, it should be inserted all the way at the end. So any positive integer, say 4, should be inserted all the way at the end. Okay, all right. So that's the problem. So what you see here is, if it's a positive integer, there's nothing to worry about. You have to just insert that at the end of the list. Only if it's a negative integer, you have to traverse through the list from the beginning and then see when you come across a positive integer. So you have to stop there and insert that negative integer in between. Okay, all right. So I added all this code and uploaded them in Canvas. So download the latest zip version and then unzip all those files, and you can see this as code number 9 in the zip file. So let me show that here. So we are going to have all the functions in the list class as we have seen before, which are the insert function that to insert at the end of the list. I have also included the insert at index, even though we don't need that. So this is a new function which we are going to see, insert element. Okay, so the main function will have the user input the list size. After the user inputs the list size, you create an empty list. So integer list is an integer object, so it's a list object. Then you go through a for loop and ask the user to input the element, and that's the kind of a sample output that we saw in the previous slide. So let us look at the code, and then we'll look at the linked list also, how things get inserted. Okay, all right. So now as you can see in the main function, as the user inputs the value, you call the insert element on the integer list object and pass the value. So you don't pass the index because you don't know where that should be inserted from the user point of view. So you just pass the value. Now again, this is insert element is a member function of the list class, so you have to call that on the object, integer list object. So you should all be familiar with this by now. And then after every element gets inserted, I am printing the contents of the list. Alright. Okay, so if the data, so this was the variable I'm using to capture that value passed. So if the data that you want to insert is greater than or equal to 0, so you see here this is also an example to illustrate how you can make use of some other member functions in the list class. So you don't have to really rewrite the code to insert at the end of the list. So already there is a function for that called insert, and it takes only one argument, that's the data that you want to insert at the end of the list. So you can simply call this function, and that will take care of inserting the data at the end of the list. So you don't have to do anything. So if the data is a positive integer greater than or equal to 0, you just call the insert function, and that will insert the data at the end of the list, and then there's nothing else you want to do in the insert element function. So you can simply return from this function. So this is a way you can return from a function, and there's no return value. You just put void return data type. So we can just say return. So you have to really deal with this function when you have to insert a negative integer. Alright, so that's what the code we are going to see. So we are going to use a logic similar to what you have seen so far to traverse the list. Use the two pointers, current node pointer and previous node pointer. Okay. So let us go back and also look at this figure. So let us say you want to insert this negative 45, okay, to this list that currently has 23 and 10. So we have a head node, and the next node address in the head node is 200, that's pointing to the first data node, and then 70 to the next data node. So the code currently has, say, the current node pointer stores the address of the node next to the head node. So head pointer stores the address of the head node, and when you call the get next node pointer function on the head node, on the head pointer using the arrow operator, you get this 200. That's the value of the next node address. So that is stored in the current node pointer. And previous node pointer is initialized to head pointer. So previous node pointer is also 100. That means it stores the address of the head node. That's where we are initially. So now we check if current node pointer is null or not, and current node pointer is not null. So we get inside the loop, and inside the loop we check if the data at the current node is positive. You see, as I went through in this example, you are going to use the current node pointer to traverse through the list, and as you can see, you are going to see all negative integers. So current node pointer will pass through all these nodes that have negative integers. So the moment the data for the current node becomes positive, you have to break out from the while loop and insert the new data right there, in between the last negative integer and the first positive integer. So that's why in this code you see, if current node pointer arrow get data is greater than or equal to 0, you break from the loop, from this while loop. Okay, because that's the time you have to insert that, because you see all this code that you are seeing after this if statement here or to insert a negative integer data. So if current node pointer the value of the current node is a positive data greater than or equal to 0, that means we have reached the index or position where we want to insert that negative integer. So you break from the loop, and after the while loop you come out of the while loop and take care of inserting that new data like we used to do before. Else, that means you don't need to have an explicit else, because the only thing you do inside if block is breaking from the loop. So if you encounter data that is negative, that means you're still in the negative integer among the negative integers there. So that means you have not yet reached a positive integer. So you can move the current node pointer to the next node, and this is how we move as before. So first make the previous node pointer take up the value of current node pointer. So like in this case, so we have to look at this example for this. So to insert a -3, so we have gone through here. We start with the head pointer and current node pointer and previous node pointer. So the current node's data is still negative. So we'll come back to this example as a second example. So look at this example first. So current node data is negative. So that means we don't go into the if block, move the 2 pointers to the next node. So move the previous node pointer to 200, so it's pointing to this node, and current node pointer is moved to the next node, so it's pointing to this node at address 70. So now check the current node's data, it is still negative. So move the 2 pointers to the next node. So previous node pointer moves to this node at 70, current node pointer moves to this node at 900. And now the current node's data is 1. So that's the time to insert. So when current node's data is 1, you break from this while loop and come out of the loop. So you create the new node. So you're going to create the new node. Let us say the new node is set up at address 300, and the new node pointer is pointing to that address. And then you can enter the data, which is a -3 that you want to insert, as the data for that new node. And then all you have to do is break this link from the last negative integer to the positive integer. So that means this previous node pointed by the previous node pointer, its next node pointer should no longer be this 900, because that's currently pointing to this first positive integer. So what we have to do is we have to override this with the address of this new node. So we can do that by setting previous node pointer arrow set next node pointer and write the new node pointer. So the new node pointer stores the address of the new node, and the previous node's next node pointer address can be set to that 300. So instead of 900, the previous node now has 300. So you have established this link from the previous node to the new node. And the last thing you have to set up is this, the link from the new node to the current node. So how you can do that is new node pointer arrow set next node pointer to current node pointer, and that will make this 900 to be the value of the next node pointer in this new node. So that's the last statement that you see, new node pointer arrow set next node pointer to be current node pointer. And that way you have now set up the link from the head node. You can go to -4, -7, -3, and then to 1. Okay. So that's for inserting in between the last negative and the first positive. Now let us come back to this code to insert the first negative integer. So currently the list has all positive integers. So in that case, what's going to happen is the current node pointer will be set up to point to the first data node, and the previous node pointer to the head node. Get inside the loop, and right away current node's data you see as positive, it's 23. So that means we have to break from this while loop. So come out of the while loop, set up the new node with data -45 at say address 500. So new node pointer is pointing to that. So you see the previous node pointer is storing the address of the previous node, which is in this case the head node itself. And that's okay, you can still use the previous node pointer to access the head node and change the next node pointer address of the head node. So this code is still applicable. So previous node pointer, which is now pointing to the head node, arrow set next node pointer, you pass the new node pointer address, which is 500. So instead of 200, the next node pointer value is now 500. And the current new node's pointer, next node pointer, can be set to this value of current node pointer. So that means that way you have this 200. So new node's next node pointer value is now current node pointer. So that way you can set up this link, and that way the first negative integer gets inserted right at the beginning of the list. Okay. So where is this useful? In real world, say let us say you have a queue or a list of people, okay, and you have the female and male people. So you have all females people first, followed by male people. So a new incoming person, depending on whether it's a male or female, So if it's a male, that's like a positive integer. So that person should get inserted at the end of the list. It's a female integer, that's a negative integer. So that person should get inserted right after the last negative integer and before the first positive integer. So you can use this kind of code logic in a lot of real-time applications too. So this will be useful for you to do one of the questions I'm planning to ask you for an exam. So the logic. So you may not be able to use the code all as it is, but you can use a similar logic to solve that problem. Okay. So that way I'm trying to help you out to do the questions in the exam. So the couple of comments, let me answer them, and if there are any questions you can ask. Yes, so all these things are being recorded and posted in Canvas, and you can use them as reference. The slides are there, the code is there, posted in Canvas, and also I'm recording myself and posting the videos on YouTube. So the Canvas recording will be available for only 14 days, whereas the YouTube videos are going to be for the entire semester. Yes, so somebody has already answered that question. Okay, thank you. All right, any question on the code that we went through? Okay, so let me